So this video is integrated one, RFF classwork number 2. This little section here is on exponential functions. So on this, we are going to be graphing exponential function by hand. So you can do a table, okay, and start with, let's say, 0, 1, 2, 3, 4, and you can substitute those values in and see what you get. So if you're doing it by hand without a calculator, you go 2 times 3 to the power 0, and 3 to the power 0 is a 1, so we end up getting a 2. If I was taking it and raising it to the power 1, because that's my x, 3 times 3 to the power 1 is 3, so I get 2 times 3 or 6. If I put in a 2 for my x, so now I'm going to have 2 times 9, which is 18. And what you'll notice is happening here is I started with 2, which was my a here, and I am timesing by 3, timesing by 3. So I'm going to keep timesing by 3, so I get 54 and so on. So that's not going to fit on my graph. So let's just get what I can get onto my graph. So first off, when you are graphing these, you have an asymptote on the, let's make it a little bigger here, on the x-axis at y equals 0. Okay, and then when I look at these, I personally don't make a table, but you can always put numbers in. What I do is this number here is your A, and A is your start. So I'm going to start up at 2. And then this B here, this 3 is our B. That's what our multiplier is. So we're timesing by 3. So I'm starting at 2. I'm going to multiply by 3. So I'm going to end up at 1, 2, 3, 4, 5, 6, which is going to be slightly off here. Okay. And then we have our curve. Okay. This is an increasing exponential curve. On number 4, I mean letter B, we have 4 times 1/2 to the power x. So again, you can make a table just like I did on the last problem, but this again is going to be your A, and A is going to be our start. And this 1/2 is going to be our B, and our B is what we're timesing by. So let me first start with my asymptote, which is at y equals 0. My A is 4, so I'm going to start up at 1, 2, 3, 4. And then when I times by 1/2, I'm taking 1/2. Let me get a better point here. I'm taking, let me make this a little fatter for our point. That's a little too fat. Change it to maybe a 4. So then when I'm timesing by 1/2, 1/2 of 4 is 2. 1/2 of 2 is 1. 1/2 of 1 is 1/2. Let me just maybe make that a little thinner so I can get 1/2 in here, and so on. And so then I'm going to connect this and get a decreasing exponential graph. Again, you can always make a table if you prefer. Okay, so in this case, my A is 0.5, 1/2. My B is 2. Okay, let me get my asymptote in. So I've got my asymptote again at y equals 0. I am going to be starting at 1/2. So let me come here and get my 1/2 in here. And then I'm timesing by 2. So when I double 1/2, I get 1. When I double 1, I get 2. So I'm 2 above. and then I double that. That's going to be 4, and then 8, and so on. And let me draw my curve. This is an increasing curve, and that is my exponential graph. Again, you can use a table if you prefer. Okay, so on this, in 1985, there were 295 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75%. So this is increasing per year after 1985. How many cell phone subscribers were there in Centerville in 1994? Okay, so first off, this part right here, where it says we're increasing by 75% a year, this is going to be one of these exponential growth problems where I need to get a multiplier. I'm starting with 100%. I'm increasing by 75%, and I'm going to end up with 175%. And so my multiplier is going to be 1.75. Remember, if it's increasing, you should be multiplying by something bigger than 1. So you're going to be adding it on to 100. If it was decreasing, you would have taken 100 minus that percent. Okay, so now I am going to get y is equal to my a, which is the start, 295, times my multiplier, which is 1.75 to the power x, x being number of years. Now we want to know if this was how much it was in 1985, and we want to know how much there was in 1994, I am going to subtract that. And I am going to end up with 9 years. So I'm going to be putting 9 in for my x. Okay, so I'm going to go y is equal to 295 times 1.75 to the power 9. Oops. I'm going to put it into my calculator. So 295 times 1.75 raised to the power 9, and 45,411. So 45,000. Let me start again. Okay, 45,411.35. So if we're talking about full phones, about 45,411 phones. On the next problem, each year the local country club sponsors a tennis tournament. Play starts with 129 participants. During each round, 1/3 of the players are eliminated. How many players remain after 5 rounds? So we have to be careful. 1/3 is eliminated, gone. We don't want to know how many people are gone. We want to know how many people remain. Okay, so we have to be careful here. So we want to think about this as if 1/3 are gone, that means that 2/3 remain. So I'm actually going to be having 2/3 as my multiplier, not 1/3. Okay, we're losing 1/3, but we want to know how many we have, and that's 2/3. So we're going to start with y equal 129 times 2/3 to the power x, where x is how many rounds. Now we want this to be 5 rounds, so I'm going to put 5 in for my x. So I'm going to go y is equal to 129 times 2/3 to the power 5 and see what we get. So 129 times 2/3, or I could just do 2 divided by 3 also. Raise the power 5, let's see. Okay, this is giving it to me as a fraction because I put it in as a fraction. So I can hit math and change it to a decimal. Oops. And Let me go back up to here, sorry. And I get 16.98, 16.98, so about 17. Now, if I didn't want to have to deal with changing that, I could have done 129 times 2 divided by 3 instead of putting it in as a fraction, raised to the power of 5, and then that would have given me straight the decimal. Okay, Arnold bought a car 6 years ago for $24,000. The price decreased by 13% each year. How much is the car worth now? How much will the car be worth in 4 years? Okay. So for this, since it's decreasing, we're going to go 100% minus 13% because we're losing 13%. So we're going to end up getting 87% that we still have, and that's going to be 0.87 as a multiplier. So we are starting with this 24,000, but we need to pay attention to that. That was 6 years ago. Okay, so I'm going to start with 24,000 times it by 0.87 to the power x. Okay, and remember, x is years after car was bought. And again, that was 6 years ago. So if we want to know how much the car is worth now, what we're going to do is now would be 6 years from then. So I'm going to be putting in 6 years because this was 6 years ago, but now is going to be 6 years from then. So I'm going to put in the power 6 and let's see what we get. So 24000 0.87 raised to the power 6. That would be $10,407, and let's push it up to 3 cents. Okay, that's how much it's worth now, which was 6 years after we bought it. Okay, then they want to know how much will the car be worth in 4 years. Okay, so 4 years from now. So I am going to come back to this equation. I'm going to come back to this equation. And if I want 4 years from now, that means it's going to be 10 years from date bought. So I'm going to put a 10 in. So I'm going to go y equals 24,000 times 0.87 to the power 10. And I'm going to see what we get. So I just hit second and enter and it retyped it for me. And then I can just change this to a 10. And I get $5,962.16. And that's our answer. Okay, on these ones, we are going to be completing a table. They have to tell us what type it is if they only are giving us 2 values. So we know it's exponential. So that means that these need to be in the form y equal a times b to the power x, where x is our 0. Okay, where x is our 0. So I'll put so in this case, what I would do is we need to figure out, we don't know our 0, okay, because that would be our a. So a would be our 0. So I need to figure out first what my b is. So I'm going to take 2 times b, 2 times b squared, 2 times b cubed, 2 times b to the 4th, which means this is going to be 2 times b to the 5th. So I'm going to get 2b to the 5th is equal to 12. I'm going to divide by 2. I get b to the 5th is equal to 6. I am going to now take the 5th root of both sides. So when I take the 5th root of this, I get b. And then I'm going to take the 5th root of 6. And let's see, we're going to have it be an approximation here. So put it on my calculator. So to get to the 5th root, you can just press the math button. Okay, the math button, which is right underneath the green alpha math. And when you press math, number 5 will do any root. And we want a 5th root of 6. And we got, let's say, about a 1.43. Okay, b is equal to a 1.43. And they want us to complete this table and then write an equation. So at this point, what I'm going to do is I'm just going to keep this number in my calculator, and I am going to times by 2, because that's what my first number is here that I know. So I'm going to times it by 2, and I get, let's say, about a 2.86. I'm going to times this by my I'm going to times this by my answer up here. Okay, so I'm going to keep times it by that 1.43. I'm just going to keep it in my calculator, but you can just do 1.43. Now you probably won't get exactly 12. So I'm getting about a 4.09, 4.09. And again, I'm going to times it by this answer again, that 1.43. So I keep times it by 1.43. I get 5.86. I'm going to times it again by my 1.43. I get 8.3, 8.39. And then let me just double check it and times it. Let me go up here and start one more time. And you see I get exactly 12. Now, if I did it and I go 2 times 1.43, and I keep timesing by 1.43, and I keep timesing by 1.43, you're going to see that I am not going to get exactly 12 here. So if you're trying to double check and you are using the approximation 1.43, you're going to get rounding up to 12, but you're not going to get exactly 12. Okay. Then on this, they wanted us to write the equation. Okay. For this, myself personally, I would, on a problem like this, if I had a free response situation, I would probably go y is equal to, and I would probably start with this, which is not our normal start. And I think I'm going to just start with our 0. It's going to be too complicated for this one. I'm going to start with our 0. Okay, this is our 0. It's approximation. So, but I'll keep it in that form. So y is equal to 4.09 about times 1.43 raised to the power x. Okay, and again, this is an approximation. If I put this exactly in, it's not going to get exactly 12, but we're trying to get the best answer we can out of our choices. Okay. On the next one, I'm going to go through the same process. It's a little smaller. So I'm going to have 256 times b. I'm going to have 256 times b squared. And this is going to equal 256 times b to the third. So I'm going to go 4 equals 256 b to the third. And when I do this, I am going to divide both sides by 256. So I'm going to have 4 over 256 equals b to the third. I'm going to be taking the cube root of this. Okay. So let me just get it on my calculator. I'm going to hit the math button. I'm going to go down to number 4, which is just cube root. And I'm actually going to put it in as a fraction. Alpha y equal. And I'm going to do 4 over 256. And I actually get a nice answer. I got a 1/4. Or if I put it in my calculator as a decimal. And again, I'm taking the cube root. Let me write that. Taking the cube root. Okay, taking the cube root. Or 0.25 if you have it as a decimal. Okay. So now when I'm trying to fill in the chart, okay, and here, let me just get rid of these. Okay. So I am going to take 256 times my 1/4 or 0.25, and I get 64. And I am going to times that by my 1/4. And I get a 16. And then if I times that by 1/4, I get my 4. Now we need an equation. I need to go backwards and get my 0. So you might notice that I am timesing by 1/4, but really, if you want to think about it, I'm dividing by 4 going this way. Okay. It is a 1/4, but I am really kind of dividing by 4, which means going the other direction. I'm going to be multiplying by 4. So I'm going to take my 256 times by 4. Oops, 256 times by 4, and I get 1024. So my equation is going to be y equal 1024 times 1/4 or 0.25 to the power x. Okay. Okay, on the next problem. Okay, on this one here, we're gonna, this 2,4 is going to be a point, and this 0,7, and this is exponential. So again, we're trying to get y equal a times b to the power x. My a is going to be 7 because that's my 0. So I know it's going to be y equal 7 times b to the x. I am going to put this point 2,4 in for my x and y. I'm going to put 4 here, 2 here. I'm going to divide both sides by 7. I'm going to then take the square root of this, which is not going to be a nice number. The top is going to, square root of 4 is nice, but the square root of 7 is not nice. So let's see what we get. So I'm going to take the square root, and the square root button is actually on this x squared. It's the blue one here, so you have to press the blue second button. So I'm going to press the blue second, and then I'm going to press the square root, which is on the x squared button. And I'm going to do 4/7, okay? Or 4 divided by 7, either way. It's not going to be a pretty answer regardless. And we get about, let's say, a 0.76. So this b equals about a 0.76. So our equation would be y equals 7 times 0.76 to the power x. Okay. Next problem, letter B. Similar idea. This one's a little nicer. My A is going to be 1. Okay. You might notice that I was at 1 and now I'm up at 2. So maybe you could see what you're timesing by. But if you're not sure, that's okay. Y is equal to A is 1 times B to the power X. You can put in this 1 comma 2. So 2 is going to equal 1 times B to the 1. And B to the 1 is just B. So I get 1 times B or B. So this is going to be Y is equal to 1 times 2 to the power X, or you don't need to have the 1 in front. It could also be written as just 2 to the power X. Now, again, I noticed right away that this one was at a height of 1, and this one that was 1 away. Okay, we just went over 1. I was now at a height of 2. So I saw that I was multiplying by 2. Okay, that's what I saw. Okay, and that's the end of this second classwork review.